Dear colleagues, welcome to the afternoon session. Welcome. You are most welcome. Okay, I think it's time to start with the afternoon session in a very nice way, because now we will see a demo. But before doing this, you can see the title of the demo, OntoPopulis, a system for learning semantic classes. I would like to present to you the person who will present the demo. And this is Hristo Tanev. He's Bulgarian, which is very important, but he works in natural language processing area at the Joint Research Center in Ispra, Italy. So he's working on several software systems for information extraction, and his current research interests are in the area of social political event detection, information extraction, lexical learning and terminology extraction, also constructing word vector models, text similarity algorithms, and detecting fake news. So in the demo session, he will show us the system for learning semantic classes. You see the name. And this is a multilingual terminology learning system which implements several weakly supervised algorithms for terminology learning. And after this short introduction, I would like to add something personal. I know Hristo maybe from 2004 or 5, and I have very good memories because at that time, Kirill Simov, Milan Kuilekov, Hristo, and me designed a system for Bulgarian question answering. But of course, we are proud of it. But I am also proud because I invented the name of this system, and the name is Bulka, which means Bulgarian question answering, which means in English right. For the groom, I think we have to work more, right? Okay, please, the floor is yours.
Thank you, Petya. Thank you, Petya. This was a very nice presentation of me. And I myself am going to present a system for learning of semantic classes. I will stick to the demo. It will be a demo with the screenshots and the mathematics. There is a mathematics behind it. It is inside the paper in the conference proceedings. So I will not here talk about theory. So why it is important to learn semantic classes? Semantic classes are the cornerstone and the building block of every ontology. So when you want to build an ontology, when you want to automatically learn an ontology from text, learning the terms and the synonyms is the most important part of it all. And this system is doing this. It is learning terms from not annotated text corpus. It is a weakly supervised system. Semantic classes are also very important in information extraction because information extraction is working on big amounts of terms. It is using dictionaries which are dictionaries for example, if we talk about event detection system, it is using a dictionary of person positions, dictionary of titles, dictionary of actions, and all these words are forming semantic classes. So a semantic dictionary for a typical information extraction system is can be decomposed into semantic classes. That's why semantic classes are important for the an important building block of every NLP system. So this system of OntoPopulis, it is a weakly supervised multilingual algorithm for learning semantic classes. It is using not annotated text corpus, and this input for each semantic class is example a set of terms which belong to this semantic class. So it's kind of a few shot learning, kind of. For example, if we want to learn the term the class air pollution agents, we will our system will find hyperonyms of these concept terms like carbon monoxide, lead, nitrogen oxides, and also related concepts such as acid rain. The point is that this is a statistical system. So if we want to learn semantic category, it's not possible to expect 100% accuracy. So the system is giving a suggestion. It is giving suggestion to the domain expert in the form of a list of weighted terms, where each term has assigned a weight, a confidence. And I'm giving another example here. The system, if we want to learn a concept like environmental disaster, the seed term set are hyponym concepts like water pollution, climate change, air pollution, and oil spill. And then the system is going to suggest a list of terms which are supposed to be part of this environmental disaster category. The algorithm performs two processing steps to learn the new lexical items for the input concepts, extracting complex patterns and learning new terms. So I'll give an example what they look like. For the category environmental disaster, the seed set is environmental disaster, the concept itself, the water pollution, and climate change. So let's say these three terms. So this is a real example. And then the system learns these contextual patterns. Threatened by disaster and land degradation, impacts of disaster, pollution and disaster, impact of disaster, emissions. And so each of these contextual terms has a weight, which is based on the co-occurrence rate of the pattern with the seed set. And after that, we go with these context patterns inside the text, and we extract unigrams and bigrams which appear at the place of this Higgs, or the place of this plot. And what is coming out is this is the top of the list, the candidates for the environmental disaster category. So you can see global warming, deforestation, overfishing, rising sea. Then there are three longer terms which are disasters, but not. One of them is COVID, and then you have also natural disasters, which is okay, it's not environmental. And you can see the other ones: greenhouse gases, air pollution, acidification, heat wave, environmental degradation, rising temperatures. If you look at all of them, the system has done quite a good job just having three terms as an input. So I'm going basically to show you in the next 30 minutes. I won't take 40 minutes. To show you a set of such kind of input seed sets and the output of the system. So this will be my time. Instead of typing and looking at the results to take time, the system to take time in processing the annotated corpus, I have just reposted it for you, but if you want, after that, in the pause, we can do the demo and I can show you. So it is a little bit like a toy. It is desktop applications, we optimize for speed performance, so on a laptop, it can take like 2-3 minutes just to learn a dictionary, to learn a semantic class. It's written in Java, and it performs class learning, which I'm going to demonstrate. And also it has learning related terms and clustering terms is the other functionality. So I start with the demo. What are the first the first class I have selected is natural resources, because I believe that the environment is an important issue nowadays. It is far more important than any other sociological issues, because we're facing enormous problem nowadays with the soil, with soil degradation, with the deforestation. These are international problems all over the world. Apart from this, how the system is learning this category, we give three terms as example for natural resources: rivers, forests, and natural resources, the term itself. And then this is their output. So the outputs on the top, you can see that you have the first three terms, which is the input. So the system is consistent; it learns its input on the as the most highest score terms. And then after that, there are the terms which are suggested as belonging to the category natural resources. So you have natural, which is okay, it's a bit outside, but this is a good adjective. Then you have streams, lake, fisheries. The word resources is more like a hypernym, because but still it would be relevant if you're learning ontology. Wetlands, seas, beaches, ponds, reservoirs, creeks. I'm not going to read well, maybe to read all of it, maybe, or just go where the weight is low, and you see things like fruit and seafood and maybe deserts, which are not exactly natural resources. But the point of this algorithm is exactly this: that it not only learns elements of this category, but it also learns terms which are similar to this category, and terms which can be used when you are creating a dictionary, because this could be also a way to suggest to the ontology expert new terms and to inspire him to develop new concepts. So, is there someone who disagrees with all that? I continue. So, because it's a demo, there is another screen. We insert. So we choose the language Bulgarian on the top. So we choose. Basically, this means that we're choosing not annotated corpus of 20,000 news articles, and we insert samples for natural resources, which is the category природни ресурси, категорите природните ресурси. And this is more or less translation of the previous example in my language. And then we have this output again. On the top you have the terms, which is a good sign. And then because it is a smaller collection, then the results a bit worse. You have something from Macedonian maybe, and then you have the medallion too. But for example, we have things like okolna sreda, which is environment. It is strongly related. We have the Veta, we have Nyamukuriki, which is too specific, but still could be considered. And there are others which are probably belonging to concepts which are related to the natural resources, but they are not exactly belonging to this category. I would say this is, let's say, less successful shot, but still this can be explained because we have a lower number of documents. And it is all about data. It's all about data. As much data you have, as better the algorithm work. There will be nothing else. It is really data-based, and the other thing is that the morphology of the language, like morphology of the Bulgarian, or if you try with the Russians, it is even more complex or Serbian language, because the morphology makes the matches much more rare. So continuing with this, another example, crops. in English, we insert this Segelos, it was Bali, and we have this kind of output, which is mostly crops, but there are also some foods like beef and chicken and pork and some other things. But this also shows that we can learn similar concepts with that. So up now, this were learning of common nouns, but now I want to show how we can learn names, because the names are important part of an ontology learning. They are named concepts and also their instances, like names of people. So I have tried to insert the names of the former American presidents and use the four last American presidents and use the collection of English 100,000 English news. And then this is the output. So you can see, first of all, that apart from the repetition of the names and the repetition of the first names, we are having also Richard Nixon is the first new, really, well, the first Donald and Trump, which is very relevant because we didn't give it, and it is the last, before the last president, and the collection is before 2020. Actually, yeah, it is before 2022. Then we have Hassan Rouhani, which is a president of, which used to be a president of, in a country in Asia, I think in Afghanistan, but for sure he's president. Rodrigo Duarte, also president in at least South America. Joe Biden, Ashraf Ghani, again a president. Sorry, I forgot Lebanon, Afghanistan, sorry. Robert Mugabe, he is the president of an African country. Vladimir Putin, Olusegun Obasanjo, he was president, I think, of Nigeria. And then all the presidents of the United States, Lyndon Johnson, Jimmy Carter, Gerald Ford, again, President Trump, because it's considered a different term. It's President Trump, not Donald Trump. And the rest, I believe they are all presidents of various countries in the world. Some terms like Franklin, not Franklin, Franklin Roosevelt. So this is the list of the contextual patterns for the president category. So you see, the first one is that he got elected, that he was defeated by someone, that he has a successor, his successor had authorized, that he's authorizing certain actions. Again, predecessor nominated by that he's nominating, announces sanctions. Most of the features are featuring the word president in front. There's some more generic by telephone to deliver it. The system is done in such a way that one can actually edit the list of these patterns and then choose the most significant one before going to learn new terms. So in this way, one can increase significantly the precision, just choosing the best contextual patterns. This is all referring to the, just to say, referring to the Harris distribution hypothesis, means words which are in the same context tend to have similar meanings. That's and they would write the name of Bulgarian politicians, and so this is the most famous Bulgarian politicians. Here, maybe Ivan Petkov is a bit less famous now, less outstanding, but top ones. And so this is the output. So the output is interestingly, well, I moved a little bit up and didn't show the input terms, they were on the top. And then you have on the top politicians which have been outstanding in the last years. There are also some generic terms like the Zdravni Minister and the Minister. The list is long. What I'm showing here is just the top of the list. So this is really like a minuscule part of what is being learned, just the most important terms. And we made another thing with the international organization, another attempt. Well, we have United Nations, European Union. So these international organizations, there are not many international organizations, because simply the most organizations are inside the nations. Rarely the nations come together to produce an international organization. United Nations is the most outstanding one, then the European Union is also one of the most outstanding. And the other one, European Parliament, European Commission, International Monetary Fund, NATO, UNESCO, OPEC, and the World Trade Organization. The international, and my hope was that the system worked at the international organizations, and in fact, I think that most of these results are mostly international organizations. I don't know. I didn't check this time because I believed that the output is correct in many cases, although sometimes are partial, like international monetary or a Commonwealth is kind of an international organization. It's a political organization. It's not really an international, strictly speaking. We have the Kimberley. There's this Kimberley process, this organization which is monitoring the Kimberley, the diamonds which are mined in South Africa. And also the Organization of Russian Federation, and the International Whaling Organization. So this is the output of the system, and this in the same way ordered by confidence. And the system was more successful when we tried analyses which are more frequent, like names of singles. And we tried with the most frequent singles in the English collection. We had this nice list of American pop singles, most American pop singles, and I didn't find an label in the top ones list. But if you find an label, you can come and tell me. Huh? Covid virus. What is that? There is COVID.
Covid virus.
And he's not a single COVID. Okay. So you okay. So I owe you something. It was a bad, because I really thought this was a perfect list, but it's not. Okay, 20 euro.
It is for a concert for the others.
Wow, that's. Well, there is Johnny, who is quite generic, and they really. Okay, safe. Okay, and I tried with the name of automobile brands and inserted these brands, Mercedes-Ford, Skoda, BMW, Opel. And here is what comes out. Now this is interesting result. First of all, most of the relevant terms seem more or less correct. Interestingly, there are brands which I never knew existed, like Proton cars, the Proton cars. The PSA is the name of the group which produces Peugeot. This is something which is interesting. The only error I have seen is the Alibaba, which is selling they're selling cars, but they're not. I think I can pass to the next slide and not to bore you. And because I wanted to show how the system is working for information extraction tasks. So we have been working in the commissioning the TMA center to detect conflict events. And in order to do that, we had to learn a big amount of terms which refer to violence, protests, names of people, references to people, military ranks, weapons and vehicles, and these kind of things. I have shown how this is working in the context of finding actions which mean that the people are protesting. This is all exactly from the news we have to take into account. We gave three words which are actions about protest. Protesting, gathered, and rallied. And you see, what we have found out is, in fact, is interesting because we have found things like chanted, masked, camped, which has nothing to do, but they're still actions which are used during protest. Also, staged protest. Descended probably is also, I'm not sure about descended, but shouted and chanted slogans, dogmas. Okay. I'm sorry. And there's also some which are not obvious. The idea of all this exercise is to find terms which are not obvious and which are useful when you're creating your semantic dictionary. There are things like demanded and convergent which are definitely not obvious. And when you are creating such a dictionary, it is difficult to come up with all the possible words. On the other hand, for the Bulgarian language, we tried with 5 C terms, but we got only 4 terms, and the result was probably worse because we had less data. But when it is about nouns which refer to such kind of actions, in Bulgarian the results were not bad, and actually these results are quite promising, I would say. If you want to detect protest, you have words like protest meeting, petition, конкурси за него, but bunt, граждански протест, мълчалив, which is мълчалив протест, демонстрация, автошествие, съпротива. There are also some others which are not correct, but still there are things like обжалване which are difficult to come up with if you're just thinking examples, just looking at the text. And so, but there is no time about feelings. So I tried this to learn about the feelings, how they're expressed. The purpose will be sentiment analysis dictionary. So we have these terms, and then this is what comes out: frustration, dismay, sorrow, sadness, sympathy, solidarity, gratitude, surprise, affection, pride, compassion, anguish. It's more or less this covers the full big range of feelings, and these are the features. So feelings of sadness, and etc. Then another try with adjectives, and with adjectives again we scored relatively well. Okay, this is the last exemption. This is the last slide. So up to now, I have shown how we are learning terms which belong to certain semantic class, how we expanding semantic class. Now I'm showing how we can expand a set of domain-specific terms which are not go to the same concept. So this is mobile technology. So we just gave mobile Android, iPhone, and app, and we have got terms which are very relevant to the domain of the mobile technology using this algorithm and not other technology such as algorithm. And most of them, or all of them, are relevant to the domain of the mobile technologies. The list is this is the top of the list, and it is longer. But if someone is interested, I can show him the results on the screen. I'm back in the system, and you can see the results on the screen. So that's the end of my demo, and I thank you for this big attention. And I don't know if you're sleeping or listening, but I think you got to listen mostly. So really thank you.